morning, class. As we discussed yesterday, today you're going to be checking your homework answers and taking the notes on the Google Classroom as you're doing right now. Please remember with the videos that you can always pause as needed and continue. So here are the answers to last night's homework. I think doing 35 through 40, we're really just focusing on that b squared minus 4ac, which is the discriminant. And if it's greater than 0, there's 2. If it's less than 0, there's none. And if it equals 0, there's one solution. So if we look here, they told us what b squared minus 4ac equals, and therefore the number of real solutions. If we take a look up here, we were solving these quadratics and solving them any way you like. Number 30 and 34 and 31, those were all factorable. 29 and 33, you had to either complete the square or use the quadratic formula. If you have any questions on these, please bring them to class tomorrow. So we have studied linear, quadratic, and exponential. Linear functions are a straight line. They have a constant rate of change, and that's pretty much linear. Quadratic is in the form ax squared plus bx plus c. It always forms a u, or a parabola, and the table we're going to kind of look at. Exponential is always a graph like this where b is greater than 0. Remember, in y equals a times b to the x, a is always our initial, and b is our ratio. So now we want to determine whether the ordered pairs represent linear, quadratic, or exponential. So the first thing I look for is the constant rate of change. So if we look at this first set, the x values are increasing by 1. My y values, here I subtracted 3, here I subtracted 1, here I added 1, and here I added 3. So that's obviously not linear. We call these values the first difference. So now if we take those values, and I'm going to write them vertically, if I take my first difference and I find what we call a second difference. So negative 3 to negative 1 I add 2, negative 1 to 1 I add 2, 1 to 3 I add 2. These, which I call my second difference, these are all the same. And because my second difference is the same, I know that that is a quadratic function. So the first one's quadratic. So if I look at my second one, x goes up by 1 again. Y, negative 3 to negative 1, I add 2. Negative 1 to 1, I add 2. 1 to 3, I add 2. Well, that has a constant rate of change, so it's linear. Here, x's go up by 1 again. Here, I added 0.75, added 3, added 12. The second differences aren't equal. So let's try to see if we can multiply. 0.25 times 4 gives me 1. 1 times 4 gives me 4. 4 times 4 gives me 16. Since that one I multiplied, I know it's exponential. So constant rate of change linear, second difference quadratic, multiply exponential. And that's exactly what we see here. So using patterns. First differences are the successive differences of the y value. So successive differences means that x has to go up by 1. That's what successive means. Second differences are the successive differences of the first differences. If the differences of successive y values are equal, it's linear. That means it has a constant rate of change. If the second differences are equal, but the first are not, then it's quadratic. If the ratios of successive y values are equal and r is not equal to 1, then it's exponential. So that's where we multiply. Again, remember to pause if you need to. Okay, so please pause and do these examples. So hopefully you've tried these on your own. I'm going to explain them now. So here, x is going up by 1. -3 to -7, I subtract 4. Subtract 2. 0. Add 2. Try second differences. -4 to -2, I add 2. -2 to 0, I add 2. 0 to 2, I add 2. Therefore, it's quadratic. You ready? So try this one. So again, check out x plus 1. -18 to -13, I subtract 5. -13 to -8, subtract 5. -8 to -3, not subtract 5. These are add 5, sorry. Add 5. -3 to 2, add 5. It's linear because it has a constant rate of change. Now we're going to write an equation. So first of all, we're going to identify what type. Linear, we're going to use y equals mx plus b. Quadratic is y equals ax squared. We're not going to worry about doing where there's a b and a c. Exponential, y equals a times b to the x. A is the value when x is 0. Write the equation using what we know. So, if we look at this, x goes by 1. 32 to 18, oops, I gotta get off text. 32 to 18, I added, or subtracted 14. 18 to 8, I subtracted 10. 8 to 2, I subtracted 6. 2 to 0, I subtracted 2. Second difference, -4 to 10, or -14 to -10, is I added 4. -10 to -6, I added 4. -6 to -2, I added 4. Therefore, I know it's quadratic. So I know that it's going to look like y equals ax squared. How do I find a? I'm going to choose one of these. Which point makes you happy? 0, 0 looks really easy, but that's not going to help me find a. So I can choose any of the others. I'm going to choose this one. So in -1, 2, x equals -1, y equals 2. So I'm going to substitute those in. So I have 2 equals a times -1 in parentheses squared. So that gives me 2 equals a times 1. Divide both sides by 1, and a equals 2. Which means my equation is y equals 2x squared. You make a table on your calculator of y equals 2x squared. It should have those values. Practice. So we're going to write more examples. So please pause, do them, and come back. So x goes up by 1. Y, here I subtract 4, subtract 4, subtract 4, subtract 4. It's linear. My slope is -4 over 1. My y-intercept is 3. So it's y equals -4x plus 3. Here, add 1. Not adding or subtracting really anything. So let's try to multiply. Well, 1.5 times 2, I get 3. 3 times 2, I get 6. 0.75 times 2, I get 1. Oh, I'm multiplying by 2. So that's going to be exponential, which means it's y equals a times b to the x. B is what I multiply by. A is the value when x is 0. So this is y equals 3 times 2 to the x. Again, if you put this in your graphing calculator, you can check your table. And those are our examples for today. So please work on tonight's homework. which is page 594, numbers 20 through 30 even. And if you have questions, bring them to me tomorrow.